Hi guys, welcome to Computer Science at Suffolk One. So this evening we're going to go through some of the different bits in terms of what to expect on our A-level computer science course. Okay, so the A-level or the IT and computer science teams, you've got me, Dan, I'm up there on the top left. You've got my colleague Tim up there on the top right. You've got Will in the bottom left, and then you've got Pack at the bottom right as well. So in terms of computer science, you can have any one of us, or also any combination of us, in terms of when you get here. So we do the OCR exam board, and we do the H446 A-level computer science course. There is a link to the specification there, which outlines in loads of detail in terms of what the course entails and what the course covers. And also, as well, if you put OCR A-level computer science into Google, you'll also get to the page as well. But in a nutshell, the course is made up of 3 components, sensibly named Component 1, Component 2, and Component 3. Component 1 and 2 are examinations. They're both worth 40%. So overall, the course is worth 80% based on exams. And then the remaining 20% is the programming project, or the NEA coursework, which is where you will create or you will design, create, program and test something. But we'll talk a little bit more later on in terms of what the program project entails. So as you can see there, Component 1 and Component 2, they're both 2.5-hour exam papers, and both of them are taken at the end of the course in the summer term of Year 13. And then the programming project, we will generally do that with you towards the end of Year 12, and then going into Year 13. So our students in Year 13 at the moment are busy programming their projects and starting to put it all together. So these are the main topic areas of Component 1. So you can see the Paper 1 covers things like CPU architecture, binary maths, and those kinds of things. You would have perhaps looked at some similar things at GCSE. I mean, certainly you would have looked at binary and hexadecimal at GCSE, but we end up taking things a bit further, and you will generally see this through. So you have done GCSE computer science, that's great. It will give you a real foundation in terms of the A-level, in terms of how we build on things and then take you up to the next step. And binary is a really nice example, because at GCSE you assume all numbers are positive, and also they're also whole numbers as well, or integers as we call them. Whereas at A-level, we look at really big numbers, and also those with some sort of fractional values. Those are with a point as well, and how we do maths with them and store them, and all sorts of other different bits and bobs. Paper 2 is more aimed at programming and looking at algorithms and also data structures as well. So you can see there some of the main algorithms we look at are searching and sorting algorithms. Some of them you would have seen before. So, for example, the binary search and the linear search, we look at both of those. But then also as well, we look at other things, so things like quicksort, which perhaps you might not have seen before. We spend a large amount of Year 12 looking at different data structures. So whereas at GCSE you would have looked at the array, there's a whole heap of other different data structures in terms of what we look at. And one of those is what we call a graph. And graphs, we can encode things like maps and stuff as graphs, and then we do things like Dijkstra's or A-star search, which are algorithms which are used to find the shortest path. So when you're on Google Maps and you say, okay, I want to go from here to here, and it goes, right, you need to go on this route, it's using a variation of A-star search underneath the scenes. Also, when you're playing a computer game and the enemy keeps finding you, again, that's another form of Pathfinder. And we look at those, we code those up, and we look at the implementations of those. Then Component 3, the programming project. As I say, so this is different in terms of the NEA of what you get at GCSE. With the NEA at GCSE, everybody gets given a brief, and it's the same brief, and they all have to make the same thing. With A level, you decide what you want to make. You research it, you design it, you code it, you test it, you evaluate it. So it's purely originated from in terms of what you want to do. And also as well, it's again worth 20% of the qualification, whereas the NEA at GCSE unfortunately doesn't count to your overall grade. So that's a really great thing about A level. And to be honest with you, I really feel that students don't really learn how to program properly until they do that project, because you're being thrown in the deep end, and you're having to create something from nothing. And that's, I guess, to be honest, the real best thing about the best thing I think about the subject, that literally you can make anything from nothing. Just to give you a few ideas, you can see here a list of it's not an exhaustive list. Let's say we've had hundreds of projects over the past 10 years, but we've just picked out a few highlights of projects which we thought were worthy of a mention and quite interesting in terms of, as we look back, in terms of what previous students have done. As you can see, to discuss a few of them, we've had quite a few students make mobile apps. So you can see one student last year, they made a social networking app aimed at musicians, so musicians to find bands, and then also bands to find venues to perform in. A student a year or two back, they made a 3D solar system sandbox. So things like you could drop planets into a 3D world, and it would calculate the gravitational effects and work out all of the orbital mechanics, and you could model our current solar system and then also change various different things about it. That student wanted to do astrophysics at university, so that's in terms of why they picked that project to do, and that prepared them really, really well for the next step. And that's one of the things I would really say about the project. If you can pick something that's really interesting to you, you're really likely to do well at those projects. A few other highlights: a student used supervised machine learning, as it's called, to analyze the sentiment of tweets using machine learning. So training a classifier and then feeding in a bunch of new tweets and then working out whether people were saying positive or negative things about a given topic, and then visualize the results. So it gave you a snapshot quite quickly in terms of what people were saying about a given thing at a point in time. We also have students end up using hardware as well. So we've got full sets of Arduino boards and those sorts of things. So a student a year back, they made an environmental monitoring system using Arduino boards. So they've read remote humidity and temperature sensors and then fed it back using LoRaWAN, which is long range, low powered Wi-Fi, would go for miles. We have our own LoRaWAN gateway here and all the stuff. So if you did want to do something interesting, sort of around the Internet of Things, I mean, you can certainly look at doing something like that for your project. We have loads of students who like to make games. And games are fine because they're quite naturally complex, and particularly when you start throwing things like AI into the ring in terms of when it has to start making decisions as it plays against the player. As I say, they're quite a good thing in terms of to do. So you can see there's a real, there's just some of the highlights in terms of there, which me and my colleagues can think of off the top of our heads as to what students have done in the past. But I mean, really, I guess the message is, in terms of project, anything goes. I mean, we have to ensure that, there's a certain level of complexity, and it's not something you can perhaps make in a few hours. But providing that's there, you pretty much do whatever you like, which is a really, really cool thing. If you're in the market for getting a textbook, I mean, we recommend this textbook. We also have it at the centre as well, and you'll be issued it in terms of your course. It goes into just the right amount of detail in terms of the course content. So where do our students end up? You can see here, some go off to university, some go off and do apprenticeships. Quite a few go after the software developer apprenticeship. So with BT at Martlesham. Likewise, quite a few head off to university to do all sorts of interesting things. Straight up computer science. Finding quite a few want to get into the world of cybersecurity now. Also some, things like machine learning want to get into the world of data science, and also quite a few want to head in the direction of games development as well. So the computer science A-level course will pretty much prepare you for all of these pathways, because it is generic enough at sort of this point that you learn all the technical and required skills. You really learn how to program efficiently. And that's fundamentally the point of where A-level differs from GCSE. Sure, there's a whole load of new content to learn. Yes, it's more technically complex as well, but it's understanding that actually it's not just about making a solution, it's about making an efficient solution. And are we using the right tools for the job effectively, if that makes sense. Bye for now.